Well, welcome back from the breakout rooms. I want to say thank you to the ET staff engineers and the ET college mentors who were in there to assist with your designs. I know that there are some people who are at lunch, but Joanna, I think we're going to get rolling with our wrap up.
Okay, well, welcome back, everybody. I echo Monica's thanks for all the help, and want to especially give a shout out to the staff engineers, Carla and Betsy and Jerry and Brad and all the ET folks, and especially to our college mentors who have done such a nice job. I hope you've been having fun. I hope you've been building and designing and trying out new things. So let me share my screen. I have a few slides to share while we talk about what you've been doing, and we'll take it from there. So first things first, as I mentioned, let's give a big thanks to Catherine and Brianna. I so appreciated hearing their remarks and thinking about being a college student again and making those choices about what classes to take and then figuring out what your major should be. It all sounds like a lot, I know, for folks in high school, but I think, there is no one path to engineering, and there is no one path to your future career. So be patient with yourself, let yourself explore new things and take some chances. But thank you again, Catherine and Brianna. So I do want to hopefully see some of the work that you've been doing, but maybe I'll just take a minute to talk to you a little bit about the engineering design process, because I didn't really bring that up before. But what you have been doing throughout this day is you have been using the engineering design process, which is really just a systematic way of solving problems. Engineers use this process all the time. Scientists, artists, there's many ways to look at this design process, but it really just involves, first of all, trying to identify what the problem is and learn as much as you can about it. So we did some of that in the introduction this morning. Then you go about thinking about your design. How are you going to, with the materials that you have, how are you going to build the thing that you're trying to build? That's the design phase. Then you're building it. That's what you've been doing in your breakout rooms this afternoon. And testing it. That's a really important component of the engineering design process, because as I mentioned before, engineers are always trying to improve on designs and figure out how can they maximize the performance of a process. And then finally, you're deploying your design. Once you think you've got it to a point where you can really scale it and get it out there and have a reliable product, then you're putting it out in the marketplace. So I wanted to hear, maybe just for starters, is anybody wanting to share maybe what went well about their process so far? Have you had some challenges working with the equipment? Is anybody feeling like they want to share at all at this point?
Don't be shy.
Don't be shy.
We can turn on cameras, you can unmute and just talk to us. Even if your design is not ready or you don't think it's, time to share that design, just tell us about how your day went, what you experienced. I see Jillian in chat said the U School did a fantastic job in the breakout room, but I'm not sure if their camera is working now. If they want to turn on their cameras and chat with us.
While we're seeing if anybody can get themselves, if anybody wants to start presenting, I am going to show you this slide, which I think in terms of thinking about pathways to renewable energy jobs, this is, as I said, there is no one pathway, but looking at the slide, you can see that whether you have a 2-year degree or a 4-year degree, there are so many opportunities in this field. I know we have a question coming up about how long is it going to take to go completely green? And one thought I had on that was that there is so much demand for renewable energy plants and building and EV infrastructure. There's so much out there that the jobs that are going to be available I don't think we can imagine it. If you want to do something in renewable or green energy, the job is going to be out there for you. So whether you take a 2-year degree when you finish high school or whether you take a 4-year degree, you can see there's a lot. This is just a snapshot of a few opportunities. But there's the world is your oyster. In fact, the job market is so hot right now, it's very hard to keep and retain engineers in this field. Anybody feeling like they want to start sharing a little bit?
I saw the U School turn on their camera while you started sharing, but then they turned it off. So oh, there they are again.
Yeah, I'll stop sharing for a minute.
Do you have a group? Oh, can you unmute? 1 second. There's it. All right. Don't be shy. It's okay.
Okay, hang on. So what we have over here, we've got the two solar panels in parallel. We've got the two LEDs, the red and the blue. It's really easy to tell when the blue is on. It's not that easy to tell when the red is lit. So as part of the challenge of it, I guess, is that it's lower energy, so there's just less to see.
Less light.
Yeah, it emits light.
Cool. So if I understand, you put 2 solar cells in parallel to try to get twice the energy delivered to the LED, which is great.
Right, because we had it, the 2 lights in parallel with the one, but it seemed like either the red or the blue was lighting, and
Okay.
you couldn't get both on.
And then how about with what's the circuit that you have going with the wind turbine?
Okay, I sent Monica the video of myself huffing and puffing on that one.
Oh, great.
I didn't want to do that live.
Okay, so it's a human powered wind turbine. That's all.
Human wind power.
Awesome. Well, that's so great. And then what are you using for the tower for your wind turbine there? Oh, okay. So I see 2 wind turbines.
Just the one light, but you don't need 2 people to blow at once, because if you blow on this one and while it's turning, start blowing on the other one, you'll get the blink on.
You get it to come on a little bit. I got it. And then what are you using for the tall tower? What materials were you using there for the tall tower for your wind turbine?
For my tower?
Yeah.
Like, say what I have. Okay. So I have a ruler.
Yeah, that came in the kit.
Yeah, it came in, everything in here came in the kit except like the cardboard. So I have a ruler holding it up, and then I have
Ingenious.
cardboard right here and right here, and I have like a little glue stick holding up the back.
I love what ingenuity there to use all the materials. That is fantastic. Well done. Well done. And it looks like you have some windows in your classroom. Were you able to get the solar panels to light just from the light coming through the window, or did that not work very well?
So we have 2 rows of fluorescents.
Got it.
Yeah. So even if, because it's not a very bright day, even though it kind of looks like it in the camera, we were able to like hold some stuff up higher, like right under the fluorescence. We were able to get things to light that way. And then, but if we were really challenged, what was our solution?
Oh, the flashlight, using the flashlight.
Oh.
Yeah, so
Man, the ingenuity of this classroom is amazing. The U School in Philadelphia. Well done. Does anybody else want to show their design there? No, not yet. We're not ready yet. Okay, no problem. Well, thank you so much. That was really great.
I have to say, I just shared with you the video of this. I don't know if you want us to play it now. We can, right? See if I can. So I'm gonna share my screen and I'll share it with everybody
Okay,
so we
awesome.
can see. All right. And all right. Can everybody see my screen? There we go. With a quick clip, just 2 seconds.
But I saw it light up. I saw the flash of red there. So
They made it work. I have to say,
they
super impressed
did.
you,
They
school.
used all of the materials in very original ways, even a glue stick as a support post. I think that's fantastic.
We don't need a hairdryer. We're good.
No, who needs a hairdryer?
Love it. Fantastic. Well, I have
could I also ask the U School, was there something in particular that was kind of a challenge? That I mean, certainly providing a wind source might have been a challenge, but was there something? How was it working in your team? How did you work together?
Yeah.
The only thing challenging, I feel like it's trying to find like where the wind solar thing comes in, like this part, where that can come in our like setup.
Trying to incorporate it.
Yeah, trying to.
Oh, trying to figure out how to incorporate
And
it.
also because it's counterintuitive wiring, because it's designed to be like a motor rather than a generator. So
That's right. It's
Well, like,
designed, if you plug those,
we figured it out because in our first design in parallel, when we would blow on the fan, it would make the light dimmer.
ah,
So we're
okay.
like, wait a minute, that's the opposite of what should happen. And that's when we sort of figured out it was wired the opposite of how we were thinking.
Great. Yeah. If you were to hook that motor up to a battery, you'd be able to rotate that fan really fast, but rotating it in reverse and getting it to generate electricity is using it as a generator. So great. Yeah. That is kind of confusing though. I know. Well done. Well done.
I have to give just a shout out to U School. That was awesome for sharing. Thank you for being brave souls. Hopefully we'll get some other participation from other schools. I'm looking at you, Delta High School. And maybe Mr. Lynch in his classroom if he wants to hop on the camera. But great job, U School.
Yeah. And I think I think you heard from the U School about trying to use all the resources in unique ways. Engineers have to do that all the time. They can't always build their dream design because they have limited resources or limited schedule or most often limited budget, sometimes all three. And so really trying to be creative and think outside the box about how you can do something on schedule and on budget is a big part of the engineering design process, and why it's so great to work collaboratively in teams, because that team energy and those creative juices often can help you lead to the best design. So again, shout out to the U School. Thank you for being brave and starting first. I could go on with a little bit more of I just was going to show again the slide. Maybe I'll just share it and show the slide let me just find it. I just wanted to just talk again about kind of these opportunities between 2-year programs, 4-year programs, and then even going on to become a specialist in an area in graduate school. Like if you're really thinking, we had a few questions in the chat about infrastructure and how can we make infrastructure more green and essentially provide the infrastructure that's going to be needed for clean energy. That would be an urban planner or even an environmental scientist. Both of those fields are incredibly interesting, and there's so much thinking that's going into what will our future cities look like? How will we build more resilient cities and towns to combat the effects of a changing climate, where we're getting more severe storms and more flooding or more drought? What kinds of things can we do? An environmental engineer, getting a master's in that, you can get into specialties, like you could become a water engineer. You could learn about ways that we can conserve water or ways that we can build more resilient structures against the forces of water. You can look at a hydrological engineer looks at how water flows on the planet. There's just so many things that are interesting, I think, that you could continue to learn about if you're fortunate enough to be able to go to school to continue to go to school beyond.
Joanna, I'm
the
sorry to
graduate.
interrupt you, but I think that Delta High School is ready to share, but you have to unmute the other camera.
All right, so
So I think they're trying to figure it out because I think
Oh.
their visual is on one, but their audio is on another one.
oh well, I can't wait.
They're looking at this camera,
Delta.
but this camera doesn't have audio. Can we hear you now? No, I can't hear you. I think your other device has your audio working well.
Okay, hold on.
Now we can hear you.
Oh, you can. Okay.
Yes.
All right. So this is Deacon. Where's your partner?
I don't know where Joe is.
Joe's over there. All right.
Hi, Deacon.
They have the solar panel hooked up here, and the blue light's working. I don't know if you can tell.
It's hard for me to see, but that's great. So that's a direct connection, solar panel to the blue light. Great. Oh,
Yeah.
Got it.
And then here, and then if they've got the red light over here, and if they blow on this, it'll light up the red light. Here, go ahead, blow on it. Oh, you're not getting it. Hold on.
They're a little
It
bit
was
of
working.
Well, believe me, you don't even know how often that happens during testing where it works. Might be a loose connection, maybe just in the moving it might have just joggled the connection.
Yeah, probably did.
Yeah.
Just for
I love your
Anyway.
structure too, just to do that so quickly with just the time that you've been spending on it. You've got a nice solid structure with like it looks like kind of a truss frame on the bottom, and then you've got this nice tower for your wind turbine. Very nice hybrid design. I really like it. Did you find so other than getting the connections to work, because these wires, these alligator clips can be pretty fiddly. Did you have some other challenges that you came across as you were working?
not necessarily. It was mainly just making sure every connection was secured.
Right. And how did you come up with your design? Were you thinking about it just even before you started going at it, or did you do some research? How did you come up with that cool design?
I thought of like the Iron Man towers that hold all the wires and put it together.
That's awesome. That's really great. So let's see. What can I try to see with the light on? Are you getting the blue light to shine, or do you have to add additional light to get that blue light to shine?
It'll shine. It's just not necessarily bright.
Yes. So it's shining to you. I can't totally see it, but
Here,
I think
let's
it's
see if we
shining
can-
right now.
Yeah, it is. Hold on.
Yeah, it is.
oh yeah. Okay. Great.
Yeah,
Can you
there
see
you
it?
go.
Yeah. I could not
job.
get a blue light to shine with my solar panel. So did you just directly connect the LED to the solar panel for that one?
Yeah.
Awesome. Okay. And then a human powered wind turbine at the moment, creating your red circuit. So what do you feel like was the most fun for you on this, for you and your team?
Building the structure mainly.
Yeah. Well, it's very good. And it looks like it took it allowed you to be a little creative with the materials you had. Did you have more materials that you could have chosen from, or were you pretty limited?
They had cardboard, but I didn't see the need in it. I just used hot glue and tape and then the popsicle sticks.
And it already looks pretty structural, even using hot glue. It already looks like it's pretty sturdy, even in this short time. So, well done, Deacon. Thank you so much. Thank you.
Awesome, Deacon.
Do we have? Great. Are there any more from Deacon? Excuse me, from Delta High School?
Anybody else want to come up?
Don't be shy. Even if you want to talk about some struggles you had, I'd love to talk through them.
Okay, come on, come here, right here.
You got this.
I don't like this. Um,
Go ahead. Talk to them.
basically, it's just Shrek's outhouse with the light in it.
And
Show
where
the
can I see, where's the,
light.
oh, there's a
it.
door. Love it.
Yeah.
Great.
I don't know why this. Show the top. But it has a
Okay,
solar
and then
panel.
the solar panels on the roof.
Yeah.
Great. And so you get a light in the outhouse whenever you need it, except for you're gonna need to think about what can you do at night? This will be a daytime
Oh,
out.
yeah.
You got any thoughts on that?
Probably a wind turbine, but then it wouldn't really work when there's not a windy day. Dark.
You could add some wind, but and then another thing you could do is you could add a battery so that you're charging the battery during the day, and then you'll have the energy there when you need it for nighttime. That'll be the story for a future challenge if you guys work on it. So how did you come up with this unique design? I love it.
Well,
Was it with your team, or were you thinking about things ahead of time?
we were just making the walls.
Yeah, that's fine.
Yeah, there's a little
see.
echo.
How about now? I think I
Perfect.
muted. Yeah.
Perfect. Yeah.
Yeah. We were making these walls.
Yeah, let me turn this down.
Oh, it was just working. I'm not sure what happened.
Yeah, that happened to
Yeah,
me
try
so
that.
often in my classroom too. It's confounding. Okay, perfect. Yeah. So you
Making the walls.
immediately kind of thought about that design for the walls, which is great.
Then yeah, we said it looked like Shrek's outhouse, and so we made that.
I love it. And did you have any trouble with the wiring? That's kind of a challenge that I had. Did your team figure that
Sorry,
out
repeat.
easily?
Hear anything?
I can turn it back.
I think there's another group from Delta that has their camera on. Gentlemen in the camera, you guys ready? You guys want to share? Yes? All right. So I'm gonna swap the spotlight and go to this group here. Let's hope their audio is working. Can you hear us? We cannot hear you.
Well, I gotta say, I love the Christmas sweater.
Well, hold up your design so we can see it. I see some amazing.
Is that a face or a tree? I'm trying to
I see a face.
You see, I think I see a face too. Very, very creative. We
I see
got
some
sort of an
inside.
avant-garde.
Yeah, there's
An
faces on top
avant-garde
and inside
hybrid
the house.
powerhouse.
Very nice. Yep, I see it inside too. Very nice.
Okay, so we have a nice sturdy house design. What's going around the edge? Is that string? I
What's
can't.
going around? We can't hear you. If you want to type it in chat. We're going to problem solve this one.
Is this a different classroom at Delta Heights? Do we have multiple classrooms?
Yes.
Oh, that's great.
We have multiple classrooms. Oh. Well, we'll come back to you guys while you try and figure out your audio. Are there any other groups that want to share? No? I see another group from Delta. Yes. Okay, I saw another camera come on. Hi, Delta High School.
Do that.
We can hear you. Look at this design.
This is our power. Two fans or whatever propellers.
Yeah, we have two fans and then the lights down here. If you can, it's not very structurally sound. It kind of falls over.
So
It's okay. It's okay.
originally we had a like square base and it kind of just decided to go place we didn't intend. And shush. So the light's down here and the wiring comes upwards. We were having issues with the solar panels.
They all broke.
They all broke.
They're back.
See it better.
Do we want to do a demonstration?
Yeah,
we
so
can.
two separate directions to get like more wind power.
Human powered.
Yeah.
Yeah, it didn't really work with only one fan. Like it barely worked. So we decided to double the power, and now it kind of works a little bit more.
At best, and he's a little janky, but he's lovely.
Yeah. Anyway,
All right, ready? You gotta turn it this way.
okay.
Well,
Go
I
this
think that's a pretty amazing design for the time that you had available to build this. I really like your kind of tripod base structure so that you could get a really tall wind turbine tower, because you know the higher we go with our wind turbine designs, the better air we can capture. So the fact that you've got the tallest tower we've seen today, I think really helps you see, you know, it's a way to better capture the wind. So if you can shore that up structurally, you're on to something really great there.
Got it.
Yeah. Yeah, we definitely took inspiration from the turbines
So the
and
turbine,
how tall they are.
yeah. So the turbines themselves just are kind of like big poles, and that was the base thinking. But
Yeah.
since, you know, we can't go like underground, we had to make a tripod-esque base with a square that just decided it didn't want to be a square.
Yeah. You guys show it.
So
Okay. Oh, it's not
not
working. It's
working.
not working.
the wiring is not great.
See it? Kind of lighted. Yeah. Yeah.
It was the clamps
Yeah.
were off-centered, so it
Okay.
was not clamping all the way,
Yeah.
so its connection was not
Anyway.
fully intact.
Yes,
So, like,
you
can't
know,
really
those
see
connections can be
a
very
little
fiddly.
website.
We don't have a whole lot of metal to metal contact there to work with. So even a little jostling can kind of mess up that connection. I had the same problem too. And isn't it always the case when you go to display your design for testing, that's when it doesn't work, even though it worked beautifully beforehand. I hate it when that happens. Anyway, thank you so much. That is wonderful. Do we have one more group now? I was thinking that when I was on mute, we didn't hear the echo. I thought maybe I was the problem being off of mute, but does another person from another team from Delta want to present?
I think we have one more up here at this camera. Let me spotlight this for everybody. There it is. Now let's see if we can hear them. That's the test. We can see your amazing design, but let's see if we can hear about it.
We can.
Go ahead.
We modeled Shrek's outhouse.
I see a theme in Delta High School.
I feel like I need to go watch Shrek again because I don't remember anything about the outhouse.
We set up a fan on on 3 sticks over here, and hot glued the top to the thing. And we have a support beam because it didn't stand upright.
Right,
Like,
to give
so
you better stability when the wind blows and things like that. Got it?
And the green and the red light are here for if the bathroom's in use or not.
Oh, clever. Like enter or do not enter.
Yeah.
You're even starting to think about control circuits and how can you make this a control system where it works kind of automatically. I love it. Or it tells the user how to operate it. Really great design. And what is your house built with? Is that cardboard or is that sticks?
It's it's popsicle sticks.
Oh, got it. Okay. Well, and I also liked how you added that structure on top of your house to mount your wind turbine assembly, trying to get that up as high as possible. But you could tell, I'm sure you had to play around with that because there's a trade-off between the stability of your house and the height that you put that turbine at.
Yeah.
What kind of challenges did you have? Was it stability mainly?
It was stability and like hot gluing the wires so they could sit in front of the door, kind of.
Yeah, got it. Well, that's a wonderful job. You've all done such a great job in such a short amount of time. I don't think I could have built anything half as great as that in the short time you've been working at this.
Thank you.
Well done to all students and great job. I really appreciate your willingness to share your designs. I love seeing that creativity. I have to say that high school students today give me so much hope. When I saw you answering the questions about things you're already doing to conserve resources, and now I see the incredible creativity and ingenuity that you have. You give me so much hope about the future. I can't say that enough. Are we ready to move on to the next phase of the presentation?
It's time. Yeah. I think the keynote speaker has arrived. There he is.
There he is. He's here.
Hello.
Well, I'm so fortunate to get to have a very special guest here today. He is somebody who is dashingly handsome, as you can tell, but he also has exquisite taste in who he decides to take out on dates. This is my husband, Mr. Bill Caudle, and Bill is a developer in renewable energy. He's been working in power production, power generation and development for about, I think, over 30 years. And I'm so excited that he agreed to join us today because he knows so much about the market and the cool things that are happening in renewable energy right now. So Bill, do you want to say hello? And I'll start sharing my screen.
Yeah, hi everybody, and I first of all thank you for the invitation, and I'm thrilled to be here. And I anytime I can talk about engineering and clean energy and what we're doing in renewables, it's a good day for me. So I'm thrilled to be able to do this, and looking forward to this talk.
Great. Well, I'm going to share my screen so you can just introduce yourself a little bit more. And we put together a couple of slides so you have a few things to talk from. So hopefully everybody sees a picture now of Bill and a little bit about his career. He currently is the head of renewable energy development at Bechtel. He received his bachelor's degree from Georgia Tech in Atlanta, Georgia Institute of Technology. He's a mechanical engineer from there. And prior to leading Bechtel's renewable energy development project, he worked for a few other power generation companies, one renewable developer called Invenergy, and another power developer called the US Generating Company. He worked in various roles there as an engineer and then a developer. Then he worked in finance and then in project construction and management. He began his career as working in the gas turbine aircraft development and testing gas turbine engines with Pratt & Whitney Aerospace Company. So please join me in welcoming my husband, Bill Caudle.
Yeah, so thanks for the introduction. Yeah, when you've been in the business as long as I have, you usually get a chance to do a lot of different things, and so I'm very fortunate that I've used my engineering degree in roles in engineering, construction, finance, project management, general management. So I think it's been quite a journey for me, and I never would have really anticipated all of it or expected it when when I was graduating with a degree in mechanical engineering, I was just happy to get a good job and do some cool stuff. So I guess my message is you don't know where it can lead you, but I think a degree in engineering is a really good start and a really good base to go off and and begin your career with. At least it has been for me.
I thought it might be a good moment to just talk a little bit about what Bechtel does. I told you my father worked for Bechtel. I work for Bechtel. Bill works for Bechtel. Actually, our son now works for Bechtel. So that probably sounds crazy to you all, but Bechtel really does work on some really cool things. So here's a really short video of some of the projects that they're working on.
Challenges.
Some people fear them.
Some run from them. Others just ignore them. We live for them. The bigger, the better.
Challenges are where legends are made, where character and values are revealed.
Leaders step up.
Teams are galvanized.
Brother and sisterhoods are forged. And trust is earned. Where innovators thrive.
Everyday heroes prove their mettle.
Dreams become reality. And progress marches ahead. We live for challenges because a better world doesn't just happen. It has to be built.
It has to be powered, connected,
Accessible, productive,
sustainable, safe,
secure, reliable, smart,
and equitable.
from designers and engineers to scientists and innovators, field leaders,
And skilled craft professionals
the people of Bechtel are at work every day.
across continents, cultures, and industries, finding a better way, making the extraordinary possible.
And bringing a better world to life. We've done it for the last 125 years, and we're just getting started.
So Bill, do you want to
Yeah.
just talk briefly about some of those projects that were shown in there and a little bit about Bechtel?
Yeah, sure. I mean, obviously, we think Bechtel is a great company. We've been working, as Joanna said, we've been the family it's almost sort of the family business. It is a family business, actually. The Bechtel family has started the company in the 1800s and is still the majority owner of the company. And we're over about 30. I think we're up to over 30,000 employees now. We have teams and people all over the world building really unique and impactful projects that that we're really, for our customers, we're trying to make the world more sustainable, connect communities with transportation infrastructure, power communities with energy, and do it in a very way that's leaves a very strong legacy and positive footprint for our customers and for the communities in which we work. So it's really a great company. You get a chance to work all over the world if you so desire. There's opportunities, and we build projects like what you saw in the video, which are big motorways that are connecting countries and communities, airports. We've built a lot of the rail and metro systems and rail infrastructure across the world. Here we're based here in the Washington, D.C. area and Reston, Virginia, where we've built part of the Washington metro system. We built the Bay Area Rapid Transit in San Francisco that I think you saw in that picture going way back in the day. We built the Hoover Dam. So there's a legacy of big infrastructure projects, but today it's even broadened out even further. It's more than just big public infrastructure. We'll talk about this. We're building a lot of renewable energy, which are smaller projects than some of the ones you saw in the video. So it's a broad range of semiconductor chip facilities are something we're working on now as well, and trying to help fill the chip shortage. So it's a range of industries and markets for customers all over the world, and so it's really it's a great opportunity, and to get to work with the colleagues that we work with, and get to work on the challenging projects that we get to work on. It's what's kept me with the company for so long, and I think the rest of our family is as well.
Well, why don't you talk a little bit about how you came into engineering? What inspired you along the way?
Yeah. So I think maybe the way to start it is to say, I was always interested in aircraft, and I wanted to be a pilot actually when I was young, and I didn't have the eyesight for it, unfortunately. So I was told I couldn't be a pilot, but so what I kind of decided, well, maybe I can get involved in another way, in aircrafts and flight, and that I've always had a sort of a fascination with flight and aircraft. So and then at the same time, I've always been pretty good at math, and like to think through problems logically, and go to step by step. And so I was actually told, you should think about engineering, because you have that sort of math background, and that might be good for you. And so that got me thinking about it. And but I will say that I was not a straight A student in high school at all, and there were definitely plenty of B's, and I think there were some pretty good amount of C's in there too, if I'm being honest. So I wanted to go to Georgia Tech. It was a school that was on my list, and sort of maybe my reach school, and something really where I wanted to be. But it's a very good school. It's hard to get into. So the path for me turned out to be going to junior college. At the time, it was called Clayton Junior College. That was a few years ago. So now it's a much bigger school, and it's now a state university in Georgia. And but at the time, it was a junior college, and I went there and was able to spend my first couple years there, and taking classes, in math and science and physics, and getting some of the basics out of the way, and demonstrating that I could do it. I was a good student, and that got me transferred into Georgia Tech after 2 years. So that was my path, and got me into Georgia Tech, and then there I really focused in mechanical engineering, and got into thermodynamics was a great subject for me, and I loved it, and kind of working towards what makes engines go, how does propulsion work, and all that topic area. And so that led me to getting a job with Pratt & Whitney Aircraft, which right out of college, which was great, and I loved it, and I got to work on these high performance gas turbine engines that went into the F-16 Fighting Falcon, and the F-15 Eagle. So it was a lot of fun, and that process kind of led me to that opportunity. And I also met somebody at Georgia Tech that was pretty impactful in my life. So that's Joanna. So it was a win-win.
Yeah, believe it or not, we met in the computer lab. I know they don't even have computer labs probably anymore in college, but at that time in the 80s, late 80s, we had to go to a room filled with computers, and I had to help Bill on one of his computer programs. So it's a good thing we met, because I helped him get to where he is today. Anyway, well, thank you. We do have some questions from students, so let's jump right in there. So I think this first one is, what are some career highlights, and what are some challenges?
Yeah. I think I would to say on the highlights. I think we're still getting some of the highlights are coming in now, right? One of the things we're doing is we're making a really big commitment into clean energy, And so this opportunity that that I have now to lead this team on not only developing and creating really interesting clean energy projects, but then being part of the company that's going to actually design them and build them as well is a real highlight, and especially considering where we are in this journey of trying to reduce reliance on fossil fuels and trying to reduce our carbon footprint and and trying to make a difference and do it faster, right? And in terms of greenhouse gas emissions and the effect that has on climate change. So it's really, it really hits home when you see some of the stuff going on in global, weather events and it's important work, and it's making a difference. We feel like we're making a small difference, but we're making a difference, and so that's a real highlight. I think the other highlight is this project that that's on the screen here was a really interesting project that I got to be sort of on the development. We developed this project. We were the actual developer of it. So we created it, and then of course we designed and built it. So the opportunity to work on it from very beginning of concept, clean sheet of paper, a field in near it was actually not very far from our office in where we live here. So it's to get to the opportunity to work on that and see it, make it, kind of bring it to life, and then have have it be able to see it come out of the get put on paper and then come out of the ground and come up and rise out of the ground and be part of that whole process from sort of beginning to end was really unique and cool, and also knowing that we had hundreds of colleagues at the company working on this. That was something that came out of myself and the team that I worked on with to create this, right? So it was a good feeling to see a whole team of colleagues working on this, that knowing that all the efforts we had put in came to fruition. So this was a really fun project, and I think this video is actually just one of the challenges. I think one of the things that when you think about with these big infrastructure projects is, of course, they're complicated and there's a lot of technical details that go into them, and building them is challenging and tough, hard work. But one of the things sometimes people don't think about is like, well, there's a lot of big stuff that goes into these projects, and how does that stuff get there, right? And it's not easy sometimes, right? These are really large pieces of equipment. They're very heavy. They will damage roads. They will break curbs. You have to do it right. And so this video here is just an example of what it takes to actually get this big equipment, actually just get it onto the site so we can put it together.
Houses, some of the heavier loads, like the heaviest one, the steam turbine generators, over 750,000 pounds. And just dealing with those types of weights going over the road requires an incredible amount of engineering and analysis of bridges, the passes that you're going to take, and then transporting it over the road an additional 27 miles to the job site. Just getting that thing moved from point A to point B required a factor 5 piece of equipment that from truck to truck was 430 feet long. This was the 6th one ever made. It was actually constructed specifically for the movements that we had here. So it's absolutely amazing to think about how you make a turn with something that long. Steam turbine generator or the other large piece of equipment kind of got cradled between two beams, and then you have these THPs on either end. which is a multi-wheeled transport device. The THP had 18 lines of tires with 16 tires per line. It's an amazing amount of coordination that had to occur for us to be able to just get from point A to point B with the minimal amount of impact to the community. All of the different organizations and entities that participated, it would have been absolutely impossible to perform these moves without their assistance.
So I think you can see, you can think about how engineers are faced with these really challenging problems, and they have to work in teams, and they have to work in kind of a methodical problem solving process to try to figure out how to, how to find a solution. And this was just one example for a company like Bechtel with great big construction equipment that they're using. I think we got another question now. Let me see if I could go to the next one. These are questions that are coming from, these are questions that are coming from students, various high schools. So here's one for you, Bill, from several high schools asked this question. What advice do you have for students who want to pursue engineering? And what college classes should students interested in the renewable energy career consider?
Yeah, sure. I think if you're going to be pursuing engineering, I think one of the things you can do is really kind of obviously get well grounded in the basics of math and science and physics. These are obviously principles that you're going to use in problem solving and in the work you're going to be doing. So it's really good to have a fundamental grounding of the principles there and the understanding. I think, getting exposed to how these projects work or how they come together, or just, getting the ability to talk to people who are working on them would be really good. If you have that opportunity, that would be really informative for people. I think there's programs out there, internships. Some schools like Georgia Tech and others have cooperative, what they call co-op students who take, work for a semester and then go back to school. That's always a good, that could be a good path as well. Takes a little longer, but you get a lot of great experience. And, I think classes, if you're interested in renewable energy, obviously there's things when a renewable energy project requires electrical, there's a lot of electrical and solar. There's a lot of civil engineering that goes into putting up a wind turbine, mechanical engineering in both. But I think again, the basics of learning before you get into the details of all that, the math and the physics that goes into that is important. And it's not just, there's a lot of other aspects of working on a team to deliver one of these projects, right? It's the details on the engineering, but it's also, we have to have, we have teams that are working on with our supply chain and buying and managing the flow of the equipment and sourcing the equipment. And so there's the whole area there in procurement and in supply chain. There's these projects can get quite complicated, and in terms of the folks who can really kind of put the schedules and keep control of all the cost and schedule and all that sort of what I call the financial engineering that goes into these projects, and then just delivering the money, finding ways to get these projects financed and get the money together, right, is also so there's a lot of different areas, I guess, is the point where where you can lean in and make a contribution. It's not just one particular area.
I was thinking about your team that you work with every day, and I was thinking there's there's economists, there's project schedulers, there's people who are looking at new innovation. You've got a very diverse team that works with you. I think it would be safe to say that if you're interested in renewable energy, you could study any number of fields and you could find a job in this sector. Would you agree?
Yeah, absolutely. There's a big demand right now, and there's more demand than there is supply, which means we need a little bit of everything, including people. One of the biggest needs and challenges is qualified people who know how to do these things, and that goes all the way from engineers to, like I said, to finance people, to accounting people, to to people who are going to be out and putting these projects together. We need the people who are actually going to drive the piles and put the panels together and work on the crews that are going to erect these turbines. So, it goes from all of our craft professionals who are out in the field working on these projects to the engineering and procurement teams that are doing the work up front.
Thank you. Okay, we're going to move on to another question. This one is related to the outlook for clean energy. We've had a few questions about that today. Why don't we take a look at these two first, and then I'll tack on those other two questions that we heard from today. So the first one is, what will clean energy look like in the future? What do you think will be the best alternative energy source for the future, and why?
Well, that's a good one. And if I had a crystal ball, I could really make a good answer here. But I think the reality is, your clean energy is going to be very diverse. It is diverse right now, and it's going to get even more so in the future, because I think we need a bit of everything. I don't think it doesn't make sense to put all your resources into one specific area when, different asset classes, different types of renewable energy have different favorable characteristics, or different parts of, meet different needs, right? So, for instance, wind, the wind projects, sometimes in different places, the wind blows really hard at night. And so that provides a great power source at night, whereas the solar obviously generates most of its energy generation, during the peak hours of the day. And then you've got to balance that with storage and other forms of energy. So I think it's going to be a little bit of everything, I guess, if you'll permit me to say that. I think there's going to be a lot of the types of renewable energy we're working on now, and there's going to be the new things coming. And so on that second question, the new types of energy and storage, there's a lot of really interesting technologies coming and being worked on and piloted right now. Demonstration projects are happening. I think with energy storage, the common thing we do now to sort of store energy from, whether it's wind or solar, to be able to use that energy, later, let's say later in the evening, when everybody gets home and turns on their air conditioners or turns on all their appliances. And so the peak load goes up in the evening, when the solar plants are done producing the majority of their energy, is batteries, right? So we have battery energy storage right now, and that's lithium ion batteries, and that's the most common. But we're looking at, I think the industry and a lot of folks are doing interesting things here. Is there's new types of batteries, right? There's these iron air batteries, which is a different process, right? Where you're sort of oxidizing and releasing current, and then you're recharging them, and it's a different technology. So it's called iron air. And then there's different types of metals besides lithium. Lithium is a more scarce and more expensive resource. Zinc is a promising new metal that is being looked at. So it could be longer duration, but most of the battery energy storage is between 1 and 4 hours. And so to be able to go longer in duration would be very helpful, right? If we could have better, more cost-effective types of storage that could last 12 hours, 24 hours. So those are the different types of batteries. And then, there's other things going on as well. Like, I know we're working on clean hydrogen, for example. There's processes like electrolyzers where if you electrolyzer essentially is you're splitting water into oxygen and hydrogen. And so you have a clean source of oxygen and hydrogen that comes from water. You have to put energy into that electrolyzer to make that happen. But if you connect that energy source to a wind farm or to solar or a combination of the two, so that you're providing green energy to power the electrolyzer, then you have a clean source of hydrogen, and that hydrogen can be a replacement fuel for gas, and it doesn't provide, and then you don't have any CO2 emissions when you burn that hydrogen. So that hydrogen is something. So I would say green hydrogen is being really developed and looked at and piloted right now. You can also convert that hydrogen into ammonia and into a process plant, and then you have green ammonia, and that can be stored more readily than hydrogen and shipped. And so this a lot of these things fall under the category of energy transition, and this is a really unique time, I think, in the energy industry, and I think it's an inflection point. We'll probably look back and say, okay, you remember when we were like looking at all these things? And so it's a really great time to come into the industry, because what's going to happen and some of these technologies that are going to take off, it's hard to say, but some of them clearly are, and there's a lot of promise. And we, obviously we need to do it. We need to decarbonize. We need to reduce our carbon footprint and our greenhouse gas emissions. And these things like green hydrogen and additional ways and longer ways of storage, converting biofuels and creating, another project we're working on is sustainable aviation fuel, where we're actually converting waste, municipal solid waste in a process plant and creating a fuel, a biofuel that can be mixed and with aircraft fuel right now. And that, again, reduces the footprint of flying. So, can we get there at 100%? And we're not there. We're far from that. But these are all new and promising types of energy transition. So I think it's a really exciting time is I guess my message.
We had a few questions today about like, what does this timeline look like? And I was thinking to myself that maybe if you looked at the timeline for how long it's taken for renewables to come up to be really, really viable and prolific in the marketplace, will some of these future energy sources take a similar time? Are we talking like 2 decades, or are we talking like a century? I
think we don't have time for a century. This has to happen way faster. I think we're looking at a decade, or 2 decades. I mean, if you look, that's a good example, right? If you think about it from the standpoint of where were we? I just think about the beginning of my career. We weren't really working on, and I've been doing this, I've been in the business 30 years. With solar and wind, there was no solar and wind when I started, right? It was all coal, it was all gas, nuclear, and now not only is, and so then we got, there were pilot and demonstration plants and on solar and wind, and they were very small scale, and now we've got very large scale, and we've got both. We've got very large scale plants, and we've got distributed rooftop solar, and the cost, the design and the cost to produce the energy from these types of technologies has come down so drastically in the span of less than 30, I would say in 15 to 20 years, it's come down, orders of magnitude in terms of the cost to produce electricity from these technologies. So we're the point where they were just, interesting sort of science projects, and now they are it is the cheapest energy you're going to get for powering your home, is building an onshore wind project or a utility solar PV project. That is the cheapest power you're going to be able to produce. So that's all happened in the last 20 years.
We also had a question today about how long it will take to replace nuclear power with green power. I thought you might want to respond to that.
Yeah, well, the interesting thing is nuclear is undergoing a bit of a renaissance right now. If you think about it, why is that, right? So nuclear obviously is emission-free baseload power, right? That can run 24/7 and be counted on, be reliable, and zero emissions. So it's in that respect, it's very, very valuable. The problems with nuclear have always been the cost, and early days it was a safety record. I think the designs now, what's interesting now is there are very advanced reactor designs. Our company just finished the advanced nuclear reactors, the first new nuclear plant to get built in the United States in the last 25-30 years at Plant Vogtle in Georgia. We just finished the construction and startup, and Unit 3 has just gone commercial and is producing power, and Unit 4 is going to be in a couple of months. So that's quite a milestone. And that's each one of those units is well over 1,000 megawatts. It's a lot of power. So I think that, and when you think about it, we're also working with countries. We signed a contract in Poland to start working on an engineering study for them to lead to a similar project. And if you think about why, it's energy. It's not only this need to have to meet net zero goals and reduce carbon emissions, but it's energy security, right? So when you think about countries in Europe and in certainly in the Balkans and like Ukraine, like Poland, that energy security is really, really important, right? And you don't want to be counting on Russian gas, obviously. So there's an energy security, geopolitical sort of energy security angle in addition to the emissions. But I think the safety is these new designs are very more inherently safe. We're getting the costs down, and they're not only these large scale reactors, but there's a new design of what they call small modular reactors, which are 200 to 300 megawatts each, and they can be sited much more easily and put in locations where maybe there are existing plants where you can interconnect to the grid, and they're just much smaller footprint and easier and quicker to build and to install. So so I guess the answer to the question is, I think nuclear is part of the answer, the long-term answer, along with green energy for our future, for the world's future. Nuclear will be a big part of it.
When you think about our use of renewable energy, what do you see as our country's expectations and laws around using it in the next 10 to 20 years? And the follow-up is, how can the country move faster toward renewable energy? I've also received another question where a student said, will we ever get to a point where we're using 100% renewable energy? So these are all kind of similar questions.
Yeah, sure. Good questions. I mean, that would be the nirvana state, right? 100%. I don't frankly, I don't know that we'll ever get to 100%, but if we can get to 80 or 90, I think that's really good and will make a huge difference. We're far from that now. So I think with regard to expectations and laws, I mean, it's a patchwork right now in the United States that state by state states have goals, have renewable portfolio standards that they implement and ask their utilities to meet. And so every state's different. Every state's different in terms of the resource, the solar and wind resource, right? So you really can't put a wind project in every state, and solar projects in some states don't make a lot of economic sense because the solar resource isn't very good. So it is really a patchwork. It kind of needs to be. But beyond that, I think beyond the states and in individual cities that have laws or requirements, that we've seen a big change in the demand is companies, is the corporate world, right? I mean, a lot of the tech companies are trying to buy as much renewable energy as they can to power their operations, certainly power the data centers that they continue to build because of all of the stuff we want to have online, and all of our videos and all of our internet, and now with AI, computing power is even going to go up. So there's a huge demand there, and that's all being met. A lot of it's being met by all the tech companies with renewable energy, and it's not just the tech companies. There's the corporate blue chips and your consumer companies, like Walmart and Target. And everybody has a goal to get to a net zero, by 2030 or 2040 or 2050. So that's driving a lot of the demand and usage that's going to be that's being created right now in the US.
2040s, 2030s, 2040s, 14 years away. I'm having trouble doing the math. So we're getting closer. We only have a few minutes left, so I just wanted to ask for a little bit of your advice for students, and also to say thank you so much for joining us. I think hearing from somebody who's working on this every day and hearing some of the challenges and some of the triumphs has been a real gift, and I hope the students joining us today think so too. So here's your I thought you might want to share just a few things that you've learned along the way with students.
Yeah, absolutely. I think some of the things I've tell folks, and it's actually, students I talk to, people who have worked for me, or people I've seen it come across in my career, is, it's it's not a race, that to really think about it and be patient in both your educational journey and your career journey. Don't be in such a hurry. And the key is to invest in yourself and really take the opportunity to prioritize whenever you have a chance, when you can. If you have an opportunity to do something that will really give you a good skill, or really impart some knowledge on you, maybe it's not the easiest thing to do. Maybe it doesn't pay the most, or whatever, but I mean, think about it as investing in yourself, and don't be, I mean, it's really great to have goals. I'm not saying don't have goals and don't be ambitious, but just think about, there's no set, you don't have to achieve all these things by a certain age, right? It's not a race. Just think about it in terms of investing in yourself and acquiring a good experience and skills along the way.
I know, and I think we heard from our college mentors, Catherine and Brianna, who said, enjoy your time in high school. Some of these friendships you have are going to be lifetime friendships. So it's not just about racing to get all the coursework you could get in, but it's about building and maintaining those friendships with your fellow students and with your teachers as well.
Right.
I'm a particularly cheerleader for the next one because neither you and I both didn't have an internship going into college.
Yeah, that's right. Internships, we do them. My company, Bechtel, we do have internships for college, mostly for engineering students, in college, and we use that program. A lot of companies do. And, I think internships are great for both the company and the person, because you get to learn what the company does, what the culture is, how you would fit in there, what's a day in the life like, and you get all that in maybe in a 3-month summer internship or something like that. You get a lot of value out of that. You learn a lot. And the company, gets to see, hey, this may be a great person to add in the future once they finish their schooling. So it really is a win-win, and it's very valuable. I think it's even if you're not able to get paid as an intern, it's a good thing to do. Obviously, it's good to get paid, but even if you can't, it's a good thing. So yeah, I highly recommend those. Any opportunity to get some real tangible experience through an internship. And
but I guess I wanted to add that I also feel like you really value folks that just have worked a summer job and things like that. You look at that on a resume too when you're reviewing candidates, don't you?
Yeah, absolutely. It's not always about there's always the preferred qualifications of do you have this, and this, but if it's just the fact that you have gotten out there and you've held down a job and you've taken on the responsibility of that and everything that comes with it, the obligations and showing up every day and kind of learning how to be part of a team and deal with people, that's all really valuable stuff, no matter what the job is. So if you've done that and you can demonstrate that and point to that on your resume, then that's really, we value it. Absolutely.
And last but not least, but maybe most important, what's your final word?
Yeah, I just think it's easy to get comfortable, and it's always maybe people, human nature to want to stay in your comfort zone and do the safe thing. But I have found in my career that every time I said, what, I don't really know how that's going to go, I'm not sure about that, or I don't really have that, geez, I don't know anything about that, I haven't done that before, I don't know even how to do that, but every time I've said yes and done that and gotten out of my comfort zone and maybe took a chance, it's pretty much every time paid off and led me to where I am. So I mean, I just think it's really good. It takes a little, sometimes it takes a little push, but takes some self-belief that you're going to figure it out. And you can really, lean on your network and get help to figure stuff out. But I just encourage people to take chances. Don't just stay in your comfort zone. That's the way you learn. That's the way you grow.
Well, Bill, thank you so much from me and from the whole Engineering Tomorrow team. I really appreciate you joining us today and sharing your insights with us. And will you take me out to dinner tonight?
To be determined on that, but very much appreciate it. Thank you for the invite, and I've loved the chance to talk to everybody today. So thank you very much.
Well, I'm going to hop in there and say thank you to both Joanna and Bill Cottle. Today was an amazing event, and thank you to both of you for participating and leading and giving our students the opportunity to hear from some amazing experience that you guys have in your family business there at Bechtel. Love that. And I just want to say thank you to our amazing teachers who've been here all day with their students. Thank you to those students who got up and shared with us. We love to see your student work. If you have any pictures, videos, don't forget to email them to us. If you do post them on social media, don't forget to tag us. We also have, don't forget teachers, you have exit tickets and our students have exit tickets, but we also have some upcoming events. So just letting you know, we have some more events coming up this year. Next up is going to be our pharmaceutical event and then our clean water event. But I know that in our email today, we're going to send you with the rest of the events for the year. So again, thank you to the amazing Coddles. Thank you to all of our teachers and students and the amazing ET staff that is here to support us throughout the day, our engineers, our ET administration, along with our college mentors who are all here. So have a phenomenal rest of your day and we hope to see you in the next one. Bye, everybody.